Good morning or good afternoon, students, depending on when you're checking out this video. This is the video for Wednesday, June 3rd, summer school, and this is Algebra AB Lesson 1-9. Okay, so this lesson is on patterns, equations, and graphs. Let me share my screen with you. I'm going to attempt to do a lot of this lesson out of the book, so let's go ahead and take a look. Patterns, equations, and graphs. To use tables, equations, and graphs to describe relationships. Now, I just want to say this lesson is from page 69 to like 72 or 73. If you want to look at it in the book, like just in case my little document camera here is a little fuzzy or anything like that. Okay, again, it starts on page 69, so if you want to get your book out, it might be a great time to pause and do that. Okay, now let's take a look. The focus question: why is it useful to describe a relationship using a table, an equation, and a graph? Sometimes the value of one quantity can be found if you know the value of another quantity. You can represent the relationship between the two quantities in different ways, including tables, equations, and graphs. Okay. Now, basically, the word graph kind of means picture. Okay. So the idea is a graph is a picture that's sort of showing you some numbers or some data. And generally saying, people say the idiom, a picture is worth 1,000 words. What that really means is that pictures are much easier to understand. So that's why we use graphs. You can take a look. The table below shows the relationship between the number of kites in an arrangement and the number of ribbons on the kite's tails. Okay, one kite has 5 ribbons, 2 kites has 10 ribbons, 3 kites has 15 ribbons, 4 kites has 20 ribbons. Again, this would be easier if you're looking at your book instead of a picture of my book. Point being, there's a relationship between the two values, the number of kites and the number of ribbons that there are on the tail of the kite. Okay. Now, we have these types of relationships all throughout the world. Like one car has typically 4 tires. Okay, so 2 cars would have how many tires? Let's see, Jerry. I think you're right. That's 8. Okay, good. Now, continuing on, let's go ahead. You can use an equation with 2 variables to represent the relationship between varying quantities. A solution of an equation with 2 variables, x and y, is an ordered pair that makes the equation true. Okay. Now, you may have learned ordered pairs sometime in the past, but I'll just go ahead and tell you what that means. An ordered pair is 2 numbers that represent the 2 coordinates on a graph. Okay. The x-coordinate is the first number. And the x-coordinate is anything that you would draw from left to right, a point from left to right. The second number is called the y-coordinate, and that number represents going up and down. Okay. Now, if you have a number that's going left to right and a number that's going up and down, lines from those points will have a meeting spot. And the ordered pair is where that meeting spot is. Okay. Now, I know it's much easier to picture this than just hearing me talk about it. But before we do, draw a graph, I want to go ahead and show you a problem with an ordered pair. There's identifying solutions of a 2-variable equation. So is the ordered pair 3, 10 the solution to this equation? Okay. Let me zoom this in and see if I can get this bigger. It's almost too big. All right. Well, trial and error. Let's just go with it for now. Okay. So is 310 a solution of the equation y is equal to 4x? I'm going to try to see if I can focus better. Still not coming in much better. Okay. Well, let me jump out of this one 2x zoom. I'm sorry. What I can do is just move my camera closer so that way you can see it without it being blurry. I hope that's better. I'm sorry for wasting class time like this. All right, so 3 represents your first value, known as your x value. 10 represents your y value, which is your second value, okay? Now, in the solution, y is equal to 4x. Now, which one was x? Was it 3 or 10? Let's see. You got it. That's right, Evelyn. It is 3. The first one is the x value. So 4x means 4 times 3. And the second one is the y value, okay, which is 10. Now in this equation, y is written over here, isolated by itself on the other side, the equal sign, okay? Now I want to remind you, got to be careful when you have two variables. When they're written as an ordered pair, the x value is always first and the y value is always second. But when it's written as an equation, not so much. Y can be on the left side and x can be on the right side. So the order can switch. So you have to know when you see an ordered pair which one is x and which one is y. So in this case, it says to rewrite the equation and then substitute the numbers. So I have 10 might be equal to 4 times 3. Then go ahead and do the work. 4 times 3 is 12, and then 10 is the number I have. 10 is not equal to 12, okay? So therefore, 310 is not the solution to that equation. So, in a situation like this, when you have two variables, you might have no idea how to solve them. But if you have an ordered pair, the ordered pair is giving you the numbers for the equation. You just have to know what they are. Remember, the first number, whatever it is always the x value. The second number, whatever it is always the y value. Okay? I'll let you chew on that for a second, and I'm going to pause and go to the next page. Oops. Okay. Hopefully we are back here. Okay. Let's take a look at problem 2 on page 70. It says, using a table, an equation, and a graph. Okay, both Carrie and her sister Kim were born on October 25th, but Kim was born 2 years before Carrie. How can you represent the relationship between Carrie's age and Kim's age in different ways? I actually had two friends like that, a boy and a girl. They were both born on April 4th, the brother and sister, and they were 4 years apart. So, and there's no kids in between them. Interesting how that can happen sometimes. Hey, I got a sister for my birthday present. Anyways, so continuing, what we know is that Kim was born 2 years before Carrie. What we need to know is different ways to represent the relationship. The plan is to use a table, equation, and a graph. Those are kind of your standard ways. So with a table, you just sort of write out some spots here and then fill in the information. When Carrie is 1, then Kim is 3. When Carrie is 2, then Kim is 4. Carrie is 3, Kim is 5. So each time you would add 2 to get whatever Carrie's age is, add 2 to get Kim's age. So Kim's age can be defined as Carrie's age plus 2 because she's 2 years older than her sister. Okay? So step 2, well, by the way, step 1 is basically, this is how you do a table. It's also called a chart, but basically you just sort of write out the information and quickly you can mentally figure it out. If she's 2 years older, then just write out the possible ages of Carrie, 1 through 10, Now, you could obviously go on until 30 or 40 or 50, but I don't think that's necessary. We're not trying to write out the entire person's life. We're just trying to show a relationship between the two ages. So once you've written out the younger girl's age, the older girl's age is 2 years above. So just look at the number above, 1, and then add 2 to it, and I get 3. It's 2, so I add 2, I would get 4. If it's 3, I add 2 and we get 5. I'm going to skip ahead. So let's see, if it's 6, if Carrie is 6, then Kim is 2 years older, she should be 8. 7 and 9, 8 and 10, 9 and 11, 10 and 12, and so on. So step 2 is to write it as an equation. So it says let x equal Carrie's age, and let y equals Kim's age. From the table, you can see that y is always 2 greater than x. So your equation would be y is equal to x plus 2. Okay? Y is equal to x plus 2. Now you may say to yourself, well, wait, x always comes first, but why is it that Carrie, being the younger kid, gets to be x, and Kim, being the older kid, gets to be y? Well, looking at your information, if we did it the other way, and we said that the younger girls represented with the letter y, which shows the change over time, then at some point you're going to have to say that her age would be negative. Like, for example, when Kim was born, then Carrie was -2, okay? So that's, you can't really have a negative age. I mean, yes, you can say that there were 2 years before someone was born. 2 years before I was born was the year 1967. You guys can figure out how old I am if you want to. But regardless, typically speaking, when someone's not born yet, or especially if they're not even conceived yet, then we're not even really considering what their age is prior to their birth, okay? So having said that, we want to avoid complications. So it's much easier to say, well, Carrie is X because it's easier to add 2 to Kim's age, to Carrie's age to make Kim's age than it is to do it the other way around and subtract 2. And of course, by adding, then we're not going to get any weird things like negative numbers like, oh, here's my age like 2 or 3 years before I was born or anything like that, okay? So the idea of X and Y also has something else, which I'm just going to tell you now, but I'm not going to go into detail. That'll be a later lesson. X is called the independent variable, and Y is called the dependent variable. Now, independent means that it is sort of like it's just there, doing its own thing. Dependent means that the second variable, Y, depends on what the first variable is doing. So in a situation like this, it's easier to make Carrie the independent variable because she just was born whenever she was. The other kid, Kim, her age, at least for our equation here, depends on what Carrie's age is. So in order to determine Kim's age, it's much easier to say Carrie's age plus 2, okay? So essentially that's what we've got. Y is Kim's age, so we could say Kim is equal to X, which is Carrie, plus 2. Now, the third way of doing this is to draw a graph. Now again, like I said, a picture's worth 1,000 words. So take a look. Your X values, Carrie's age, 2, 4, 6, 8, 10 years old, and the Y value, Kim's age, 0, 2, 4, 6, 8, 10, 12. Looks like the 0 got messed up in my book. Hope it didn't on your book. Regardless, if you match these two numbers, then at 0 years old for Carrie, then Kim is already 2. At 1 year for Carrie, Kim is 3. At 2 years for Carrie, Kim is 4. So you can kind of see the progression. Okay? Any questions in this so far? All right, let's go to problem 3. Now, the book here talks about using something called inductive reasoning, which is the process of reaching a conclusion based on an observed pattern. You can use inductive reasoning to predict values. Okay. Inductive reasoning basically means you sort of like look at what's going on and guess what's going to happen next based on a pattern. Now, the way I said that can represent a mathematic idea or even just like a regular idea. Okay. Like one simple pattern that we know is day and night. We know that at some point the sun's going to go down, as we call it, and then everything will get dark. Now we can change that darkness with lights and different things, but ultimately when the sun goes down, the earth is dark, and we can see the stars, the moon, and other planets. Okay, and at some point the night ends and the day starts. Okay, so that pattern, I can know pretty much with certainty that 24 hours from now it's going to be day again. Now, if something horrible happened and I was in an accident and passed away, or at least I was alive but I had no memory or anything like that, that is independent. In other words, the sun's still going to come up 24 hours later. Now, is there some time when everything will end and be completely, obliterated? Many people do think so, some don't. But nevertheless, that's a topic for a different class. Moving on, so let's take a look at inductive reasoning. Let's use the pictures here to help us. The table shows a relationship between the number of blue tiles and the total number of tiles in each figure. Extend the pattern. What is the total number of tiles in a figure with 8 blue tiles? Okay, so I have 1 blue tile here, and in this entire box, it looks like I have 9 tiles. So let's go to our table here. So for every 1 tile, every 1 blue tile, I should say, I have 9 tiles total. So it seems a little weird. I'm counting the blue one twice. Okay. But let me just be clear on this. So the first one, I have 9 tiles. In the X part of the table, I'm counting the number 1, meaning 1 blue tile, and number 9 meaning the number of all tiles in each figure. When I have two of these together, then I have 2 blue tiles and 18. 3 would be 27, 4 would be 36, 5 would be 45. Now each time I'm multiplying whatever number is in the X value times 9, because there's 9 tiles in all. So the question was, what would the figure be with 8 blue tiles? So 8 blue tiles would mean 8 times 9. 8 times 9 is, let's see, Hector, 72. You're correct. Very good. So there would be 72 tiles, okay, if there was 8. And you can go further down the page and you can see that answer. Okay. Hoping this is making this kind of clear. I just was checking to see if there was, oh no, those are just problems. Okay, text, email, or call if you have any questions. Chapter 1.9, Patterns, Equations, and Graphs. And thank you for your time.